All right, so I guess I'm going to go ahead and get started here. I'm recording now, so anybody who joins us later can watch the video. So a couple of things I want to do today. One of the activities that I want to work on and that we haven't done so far is to actually look at what's happening in the world right now related to computers. And that can be as easy as just bringing up any news site, and there'll be something related to computers that is happening right now. So who can give me an idea of something that might be going on right now that's really features computers? Okay, the iPhone X. Okay, I guess the proper name for that is the iPhone 10, right? You know, just like Mac OS X is really Mac OS 10. I don't know. But yeah, that's a big thing. Oops. We just lost power in my building. Hopefully that won't affect us. I got a UPS going, so we might be fine. Particle entanglement. Okay, higher communication. That's very good. Okay, I think the Chinese did that, by the way. They can now send satellite messages across that. Gravitational waves. You know, that has something to do with computers, right? It has more to do with physics, but certainly they do a lot of computing to be able to do that. That is the LEGO experiment. THAAD installation in South Korea, yeah, I guess so. Although I wouldn't quite count that as a computing thing. Yeah, no kidding on the UPS. So I'm kind of surprised that nobody has brought this one up. Okay, yeah, online shopping overtaking physical retail. You know what? I really want to talk about that sometime. Maybe I'm gonna let you guys read a little bit on that and bring it up for next Thursday. Okay, so try to see what you find out about that, because that has lots of interesting consequences. Like Toys R Us is just declared bankruptcy, and I don't know about you, but I grew up with Toys R Us. I mean, that was something I loved. Now, has anybody heard of Experian? Oh, we got another one. Hello. Overtaking Autodesk. Wow, I did not know that. Okay. In fact, I'd be hard pressed to say what Fusion 360 is. Okay. So, oh, the hacking. There we go. Somebody has run across this. So, yeah, Experian got hacked, right? Anybody have a order of magnitude on how many people in the US might be affected by that hack? Experian got hacked. How many of us might be affected? Millions. Yeah. That's kind of like saying 143 million. That's a little closer. Yeah, it's that big, right? So I'd say 150 million, roughly speaking, is the number we're looking at. How does that compare to the population of the US? Who knows? Oh, it's about a half, right? There's about 300 million people in the US, a little more than that, right? But yeah, you're getting pretty close to a half. So that means that about half the people we know are affected by this hack. That makes it pretty significant, right? So does anybody know what Experian is? Okay. It's something that you guys, as you know, still in high school, haven't run across. Okay, but it's something that will affect you very much, and that is your credit rating. Okay, so your credit rating is a way to let other people try to figure out how credit worthy you are. If I loan you money, wow, what's going on with your lights? If I loan you money, then how badly, what's the likelihood that you will return it, right? So yeah, Experian specializes in that. There's about 3 companies in the US that do credit reports and give a credit score to each one of you. Really? The idiots are playing with the lights. Any of the idiots in this class? And yeah, they have a huge All right, lock the light switch, okay? So anyway, yeah, if you want to buy a car, if you want to, by the way, if you want to get a loan because of to finance college, for example, or if you want to rent an apartment, they'll look at your credit score, right? And what kind of information do the people who do credit scores have? They know your social security number, okay? They know things like your credit card account numbers, all right? They know your address. They know your name, of course. They know if you've changed names, right? They know where you live. And all of that information has been hacked, okay? So all of that is available for about half the people in the United States. I have no idea what that means, okay? So yeah, this is easily the biggest identity theft ever. It's very, very true. And if you think about that, if I know your credit card, I mean, your social security number, right? I can actually take out a loan in your name, right? Assuming you have a good credit score. So I can take out a loan in your name. I get money. You have to pay for it. That doesn't seem fair, right? But that's essentially what's happened due to due to Equifax. Okay. By the way, this is why does this have a lot to do with computers? Okay. Who can give me some ideas on how computers make this more interesting, shall we say? The data is stored digitally. That is absolutely true, right? That's why computers are involved. Why is that significant? Makes it hackable, but it could have been prevented because of more secure data centers. Yeah, we certainly hope so. Okay, it's more vulnerable. Yeah, stored on a server, and servers can be hacked. Exactly what happened here. Yeah, not in a physical safe somewhere. It was digitized, and that made it available to the hackers in the first place. They could get to those machines. I want to bring something else up, and that's simply scale, right? So, for example, let's say that we want to do a big robbery, okay? Um, and so, well, shoot, we only want to make one big robbery because you have a chance of getting caught each time you rob, right? So let's just get one big score and we're out. So we're going to go to take Fort Knox, right? And we decide we're going to break into Fort Knox where they keep all the gold of the United States Federal Reserve. We grab that and we run. One of the problems we're going to have is just this. Gold is pretty heavy, right? So if we actually go into Fort Knox, we might be able to break in. By the way, good luck with that. But let's say that somehow we manage to break in, right? Maximum security, and they just go, sure, going right ahead. By the way, here are the keys. So we go down to the vault, we open the vault, and then we realize that we can't possibly get out because the gold is too darn heavy, right? So we can't actually make an escape with this, right? So that's what physical world is like, right? You could actually probably do the exact same operation and do a major robbery online, right? And then all we have to do is flip a few bits, and then boom, our account has a ton of money, right? So that's one of the things that computers let you do. One of the reasons that Experian really affected all of us is that somebody could download 143 million accounts worth of information, whereas actually carrying all that paper out of the Experian vaults would have slowed it down considerably, right? They would have needed huge trucks and pallets and all those things to move that stuff around, not with a computer, right? So yeah. By the way, they didn't actually, as far as we know, and the story will come out, but as far as we know, they didn't have a man on the inside. It was more of this was actually a vulnerability that was known. They just, they should have patched their servers and they didn't. They were not doing their job. And you know what that means? Lawsuits, okay? So my prediction, Xperia itself will go broke because they won't be able to pay the liabilities for all the people that got hurt. So that's my prediction. I'm actually a little sad about that because in a different life, I was working for Morningstar, which is a financial corporation. And one of my partners there was actually one of the guys who started Experian many, many years ago. So he was retired, he was happily retired. So it's not his fault. Okay. I want to say that. But still, it's a face that I can put with the name of the company and go, oh, I bet he's really sad that, to see what he created just go down in flames like that. Okay. So yeah, no, I know that about Fornox, but I'm simply saying that this was an easy hack, right? The easiest way to hack sites actually is to get somebody on the inside, because you know what? Some of those folks aren't paid all that much, right? And they can put in a cable for you. They can do all sorts of things that will actually get you in. So most of the time, the vulnerabilities are human, but there are some vulnerabilities that are completely computing. Okay, so be careful about that. Anyway, let's see. I'm trying to remember if I got all the points that I wanted to make. Yeah, I think we're good. I think we're good with that. So that's one of the things that I want to bring it up. I like your point about encryption. That data was clearly available. So people have already gotten fired from this, and like I said, people are going to go broke over this, and they need to, okay, because that was just too powerful. I mean, just think of one organization that has information on half the population of the United States. Risk to privacy is gigantic, right? So there it was, and it just blew up. Okay. All right. I want to do more of this as we go along. Okay. I want to talk about this because I really want to drive the point that a lot of what we do with computing has consequences, right? A lot of my students in college don't seem to appreciate that as much. They don't really know about, they don't quite understand that what we do has actual meanings to other people. And that means that you have to have some kind of an ethos, right? Some kind of ethics. So for example, when we write code, we try to make sure that the code works properly so that it doesn't just let the hackers run in through the back door, right? So little things like that that I want to try to emphasize. I hear your request about Bitcoin and virtual currency. I think that's timely, and that's definitely something worth talking about. I'm trying to remember. I should have written myself a note, but I think I put something else for next time. So this may come two meetings down the road. I'll have to look back at the chat to find what it was that I wanted to discuss next. But yeah, we'll definitely talk about Bitcoin. That's pretty interesting, and for many reasons. So I'm going to defer on that, or I'll just go on and on about it. Okay, the other thing that I want to do today is I want to go back to this technical concept of abstraction. Okay. And what I want to kind of mention today is the idea of what's known as an abstract data type. Okay, and in computing we call those ADTs. Although I think the biologists kind of have that corner, but still, that's what it means in computing, is an abstract data type. Now, what exactly is an abstract data type? What it is some kind of a representation for something that is real, that exists in the real world. For example, you guys brought up cryptocurrencies, right? So a cryptocurrency could be an abstract data type, right? And when you think of that, then the questions that you need to answer are, what kind of data are we talking about, right? So for cryptocurrency, you might have things like what the value is right now. Maybe you have the value over time. Maybe you have the algorithms necessary to mine it, right? All those are, well, forget about the algorithms. I'll take that one back. But you certainly want to know what the exchange rate is today. Maybe you want to know what the exchange rate is over time. You want to know the volume, like how many times it's traded today. Okay, that's all valuable information about cryptocurrencies. The other thing that you need to know is typically are some algorithms or some functions that do work on it, right? So for a cryptocurrency, I might have an algorithm called mine that actually does some weird mathematical computation. I think that just about describes it. And the result of that computation is one more coin. Okay, So that might be something associated with a cryptocurrency. Something else that might be associated with a cryptocurrency is an algorithm that can check that this particular coin that you're trying to pay me with is valid, right? And is not made up, right? And if you're into this kind of thing, that's where things like blockchain come into play, okay, to verify the provenance of a particular coin. So there's all those kind of related ideas, which you can think of as functions that are about cryptos, right? And that somebody has to write, okay? So you bundle all of those things together, and the name for that is an abstract data type. So the name for it might be cryptocurrency, and then it has some data associated with it and some functions that primarily operate on that data, but may do something related as well. The SNAP project that we're working towards is going to dive into this notion of abstract data types. And the example that they give is a very nice one. It's one of the most obvious abstract data types, and it's a point, right? It's a point just like the points that you see in geometry, or really more like pre-calculus class, where you have an x coordinate and a y coordinate. So if we have an abstract data type point, then what data do we need? We need an x coordinate, we need a y coordinate, right? That's the data that uniquely determines a point. Now, what kind of functions might we like to have? Here's a simple one. I want to be able to draw a point, right? So that's a function that I might want to exist. What else might I want? I may want to have something that if I give it 2 points, it tells me the distance between those. So a function that understands that particular equation. I may want to have a function that, let's see. Well, actually, here are 2 really important functions. I may want a function that gives me the x coordinate of a point, and a function that gives me the y coordinate of a point. Okay, so those 2 would be those 2 would be the functions that are related to the abstract data type point. Okay, so yeah, I'm sorry, I switched from cryptocurrencies to points, and the word points has a meaning there, as it does in all sorts of financial things. So no, these are Cartesian points that I'm talking about. Okay, and since I brought up the word Cartesian, maybe another type of functions might give me the radius and the angle to use for, say, polar coordinates of a given point, right? So that I can get its coordinates in Cartesian, and I can also get its coordinates in polar coordinates as well, right? It's still the same point, right? But I can access it multiple ways. So those are kind of the functions that go along with this abstraction, and this is an abstraction, okay? And that's something I want you to start thinking actively about. Okay, I mean, we'll do a lot of osmosis kind of stuff because that's how I like to do things, but we do want to be a little aware of what we're learning sometimes as we go along, and this abstraction is huge. The notion of an abstract data type, because I want you to write code using abstract data types, which means that you identify the important data that something is about, and then you write functions that operate on that data. Okay. And by and large, we hide everything else so that nobody needs to know really how we're storing that data. Okay, so that's the big concept for today's lab. There's actually another thing that's going to come up there, and it has to do with something called lists. Okay, I will let the authors of the curriculum guide actually walk you through lists, because they do a very good job of that. Okay, but if you have any questions, do let me know. Okay, all right. Any questions about any of those? Nothing so far? Okay, so I'm going to put up a couple of assignments while you guys are proceeding, but I'll just tell you right now what I want you to do. Last time we ended by doing Unit 2, Lab 1, okay? So that's what you were working on. If you haven't finished that, please do, okay? Because I actually want you to submit that. And And then I want you to start working on Unit 2, Lab 2. But I want us to take our time on Unit 2, Lab 2, okay? Because that's introducing multiple things at once. So I do want us to kind of go slowly through it. But those of you that like computer art, I think are going to love Unit 2, Lab 2, and particularly the oh God, I forgot what they're called, but they look like Native American artwork. I mean, it's actually pretty stunning stuff. I think you're going to love it. So anyway, so that's where I want you to move, and I'll answer any questions that you have, of course, and I'll also go ahead and bring up the week 4 material. Okay. All right, I'm going to pause this so that the folks that are watching it after hours don't have to look at us. And I want you to start Unit 2, Lab 2, if you're ready. If not, finish Unit 2, Lab 1.